we can classify science into three main branches: physics, chemistry, and biology. Let us look at what these branches are and how they work in the making of something as simple as a lime juice when you're thirsty, and understand where these branches come into play. This is where physics gets into character. Physics is concerned with the force with which one holds the spoon and the motion involved while stirring the juice fast or slow. It is the branch of science that deals with all the types of matter in and beyond the universe, their nature, their properties, and all causes and effects of manipulating them. Then comes the part where all the ingredients start getting mixed in order to give us lime juice. This is called chemistry. It deals with the reaction between two or more types of matter to form a new type of matter. For example, when the atoms of hydrogen and oxygen are mixed together in an appropriate ratio, we get a molecule of H2O, which is also called water. Interesting, isn't it? And finally, there is biology. Biology is concerned with how your body can extract the benefits from the juice. On a broader scale, it is concerned with all the living matter in the universe like plants, animals, and microorganisms, their life processes, and their relationship not only with one another but also with the environment in which they exist. Now, if you have been observant, you would have realized that all these branches, though differently listed, work together in making lime juice. This togetherness of these branches is not only in the case of simply preparing a lime juice, but also in case of every event that we see, perform, or experience in our lives. Yes, they are like friends who work in harmony. Now, whether it is physics, chemistry, or biology, everything falls under the two main categories of science. The first category is based on asking questions. This is termed as basic science, where you find crazy scientists experimenting in the laboratory like in the movies. The only thing is, they're not really crazy. Basic science always follows a cycle. Let's see what basic science is using the same example of a lime juice. The first step in the cycle involves asking questions about the origin of lime juice. For example, what are the ingredients used to make lime juice? What can be used to dissolve these ingredients? And how much of those ingredients can be beneficial? Could the lime juice do well to the body if consumed? The next step involves making an assumption or a hypothesis about the origin of lime juice. For example, we could use the juice of lemons to make lime juice. The lime juice may taste a lot better if we use sugar and salt. It could be that half a glass of water could be sufficient to dissolve all the ingredients. After we have made such assumptions, they need to be verified by experimenting. That is, we must try making the lime juice based on our assumptions and test to see what we assumed or predicted is true or rather false. After performing these experiments successfully, a conclusion has to be made where verified facts are established. That is, in this case, one can say that the lime juice is made only of juice extracted from lemons. It does indeed taste good with sugar and salt. That half a glass of water is sufficient to dissolve all the ingredients, and that drinking lime juice does good to the body. So you see, basic science always follows this cycle. Now, let's move to the second category of science that involves determining the various utilities of the now prepared lime juice. The answers might be making fruit juice concentrates, curing indigestion, reducing blemishes on skin. Therefore, this category of science is called the applied science, as it simply looks at the various uses of what is already established. Simply put, basic science is concerned with knowing something, and applied science is using what you know. We can say applied science depends on the basic science. Well, so far we have seen that science can be all fun and games. So it's about time we ask the most important question of all. Is science always this good? Or does it also have a not so good side to it? To understand that, let us look into some examples. Let's take nuclear energy for instance. It can be used to make nuclear power, which can act as a substitute for electricity and which can be much cheaper for us. Or it can be made to make nuclear bombs, which can have devastating effects. Another example that comes to my mind is the cell phone. Yes, it is true that the advent of portable phone, also called the cell phone, has made our lives a lot easier by allowing people over long distances to not only communicate faster but also more effectively. But do the benefits really outweigh all the risks that cell phones are likely to cause to our body, like the high probability of brain tumors? The question here is not about science being good or bad, because now we know science is knowledge, and knowledge is never bad per se. The real question we must ask ourselves should be, are we using science for something good or something that will cause harm? We can say science has the power to both destroy and heal. But it only depends on how you view it, and more importantly, how you use it. We do have a choice. If science is pursued with a generous and a compassionate heart, it can really change our world in more ways than one. The true potential of science is beyond our imagination. But then we can always start by letting the scientist in us ask the three fundamental questions: what, how, and why.